Okay, right. Hello. Um, there was a bit of a disaster this morning. I was doing a live stream, and um, it was only after I finished did I realize that there was an issue with my audio um settings, and there was no audio. So I did about 2 hours of just talking to myself, which was embarrassing, I suppose. Also, funnily, during that, I got a because I'm using the camera as my phone, and it uses OBS camera to do that. I got a phone call in the middle, so I was worried that would like mess up the camera, and then it was like a scam thing, a WhatsApp video call, which I didn't answer and I blocked the number. But then I looked it up, and people were getting online blackmailed for watching because someone will be on the other end stripping or something like that. So that was weird. But anyway, in the meantime, I had done quite a bit of stuff this morning and got things working. So let's see where I was up to and see if I can kind of wrap this up. I just had a lunch break and I feel a bit more energized. Um, I had to restart my machine and try to sort out the oop or run. Trying to sort out audio problems. I'm pretty sure it's working now, so I'm just going to roll with this, and this will be maybe a quicker one that I'm just going to um, deal with. So what I did on the original stream is I've made this tube shape, and then you can do a half tube, and you can do like kind of these cone tube shapes, which are quite nice. So they're adding to my ever increasing list of geometry patterns, geometry primitives. Sorry. I do want to do some geometry patterns like tiling patterns and that sort of thing, but maybe I'll get onto those some other time. And then I mentioned previously on the stream, I'd mentioned about the crash that was giving me trouble. I actually fixed that last night. It was to do with Bevy ECS, clearing entities from the world. That's now fixed, and I managed to catch it in the end by finding a reliable repro where I could do a hot reload and then attach a debugger, and then I managed to find the crash quite easily actually. So just a little bit annoying how that doesn't really give you, I didn't really get any info. I didn't get a call stack. Rust backtrace didn't seem to work, and there was no output. But anyway, that's something to think about. I think I've thought of some ideas. So just to reiterate on why that was the case, it's like if you're in hot reloading mode with plugins and you're trying to reload things, I can't be in debug because the PDB becomes locked. Now, I haven't really looked into ways around that, but that basically prevents a cargo build from working, and you know there might be ways around it. But I did think of ways of having it so you could, in a debug way, prevent the actual code from reloading. So you could detect a reload has happened, the reload build's happened, then you could prevent the reload happening, attach a debugger, and then perform the actual reload and get any crash. So I think I've thought that through now a bit more, and that's going to be helpful. I've added these little time utilities, so we can pause the delta time, which pauses the delta time, and I can move the camera around. So I was using that for debugging earlier. I can also up this to higher numbers. And go in slow-mo and so forth. And then there's also the ability to do a fixed time step, which I'm not actually sure if I'm using it at the moment. Oh, that was a slash, was it? These plus and minus keys actually scroll through, so that's basically what I was doing all of that on the stream. So now I'm kind of just doing a summary just to kind of fill in the gaps of where I'm up to. If there's anyone watching the sort of videos on the history, or on YouTube. So the main thing now is back to the material system, which I've been so slowly chipping away. And this has now been refactored. So we have an instance buffer. So I'm not going to go into the example at the moment just because I've got some slightly dodgy code which was causing a crash. And that's also probably something to discuss or think about. I did mention about I was glad I had an NVIDIA GPU because it was seemed quite robust against crashing in a bindless environment. I remember seeing or chatting with someone else about this, and they were like, "Oh, I'm getting all these crashes and so on." I was like, "Are you using AMD or NVIDIA?" Because historically, I had found AMD to be a bit more like undefined behavior on AMD drivers for OpenGL anyway were always kind of actually undefined, whereas on NVIDIA it kind of nicely made everything, you know, undefined was black or zero, and that made things a bit more stable. But now I am starting to see severe stability issues where if you index into a bindless array and it's the wrong kind of data, so the problem here is going to be, and this might just crash if I try it. Draw material. No, nothing's happening, but also nothing is getting rendered. So this is now doing something weird. So what I did was, I'll explain what I was doing. We have a instance buffer. So for each mesh batch, so for each draw call that's being made on the CPU, this will slowly change in the future, and I'll try and get it down to less draw calls. But for each batch, we push in a vec for you per instance, and that has the entity ID and the material ID for this entity. So we've got our kind of entity properties inside a vertex buffer info, and these are entity IDs that refer to entities in our scene. And then we create entities which have they have their entity ID, and the material ID is currently 0. And we create an instance, so we have that information. And then we create a buffer, a structured buffer of entity instance data, which is currently just a world matrix. This is like the draw call data. So we'll look up draw call data from entity ID, and then we'll look up material data from entity ID. So what I did just quickly at the end of the last stream, just because I was getting hungry, I wanted to finish and was sort of feeling a bit fatigued, I just printed out what the shader resource view index of this buffer was, and it was 5. And then inside the shader, we now index into entities at number 5, and then we index into that structured buffer for our entity index, and that gives us our entity world matrix. So that's where it is now. I think, yeah, I explained on the stream yesterday about having one buffer with all the entity information in versus having one per entity, and that's the route I'm going. So what I want to do is make this more robust, because what happens is if I load in and out of another demo, the actual shader resource view of the heap changes, and then this one can be dropped. So the buffer that it's pointing to, that's been allocated in a heap, has been dropped. And that's a whole problem that I have anyway. I've got a massive problem with basically dropping in-flight GPU resources. So that's stuff I'm gonna continue working through and fix up. So mesh material instance now. I'm going to, in the ECS lib, we have the render functions, and these are obviously these are basically just example code. I need to refactor it and tidy it up a bit to make it a bit more easy to follow. But I'm going to have to add a new one of these. And this is going to be to make draw calls. 3D test. So this is going to be, actually I'm moving the ones that are more reusable. I'm moving towards the top. Render meshes pipeline, render meshes pipeline colored, push constants texture. I think this one is going to be the daddy, really. It's going to be the one that we use for all meshes in the future, realistic, when I start doing a bit more advanced stuff. Render meshes material. So the way this is going to go is that we're going to bind a shader heap, which we already do, into the push constants, as well as the camera view projection matrix. I'm going to push some push constants on slot 1, which are going to be the buffer indices. So what do we have? Draw push constants. We're not going to use those in this particular shader, so I can also use that slot. And this is going to be draw IDs. And this is simply, oh, we have got draw indices in there, but we don't need them. We just want draw indices. It's called draw IDs. I wonder if we can go with one like this. And yeah, that's maybe a bit better. I think maybe if I can do this, struct draw IDs uint entity ID, and then they're named uint material ID. I'm also going to say just uint unused ID 1 and use ID 1. So I've got space for a couple more. Push constants draw IDs. And that's going on slot 1. And so if we allocate, oh, hold on. And then in debug PMFX on the mesh material instance, the pipeline mesh material instance, we've got view push constants. We'll change that around. Draw IDs push constants. Now I could use the name of these to infer them being push constants or not, but I don't really want to rely on that kind of thing. I want to kind of infer it a bit more tightly, and there's no way of knowing that that's what you want without actually explicitly saying that's how you want to put the pipeline together. So then we've got draw IDs, push constants, and view push constants. Draw IDs, push constants. Oh, this is wrong. So the draw ID push constants are going to be entity, draw buffer, and then there's material buffer. And then for example, this would be light buffer. that we would have our information inside, and we would know the slot, and then we got unused ID. At the moment, I can't think. We'll have draw, we'll have matrices, we'll have materials, material parameters, and then we'll have lights. And once I get all that working, then that's pretty much, you know, most things. We might have shadow map info, but that's looking up. That would be part of the light system, maybe. There might be other buffers. So it's there, it's padded, it's uint4 aligned. Draw IDs, push constants. Buffer, it's not draw IDs, it's buffer IDs. Buffer IDs, or push constants. Entity data. Instance data. This is getting a bit messy, and I think what will happen is that some of the example code, I still want to keep it because I want to keep it around for porting and reference, but I think it'll move somewhere else. And this, what I'm currently working on, is starting to solidify in my mind as the way that I'm going to do things for the long run, and that this, you know, very simple kind of structure that can be used regardless, you know, for different kinds of materials, for different kinds of programs, but you can kind of rely on some conventions. So VS Mesh material instance. I think in the end that won't be called instance because instancing will be for granted, and that will be just drawing big batches of stuff. So, right, so we need to get uint entity buffer, no, draw buffer. Draw buffer ID is buffer ID push constants, draw buffer ID. And I think maybe the old school way of doing C buffer is kind of, I'm seeing a reason to not do it anymore, basically. So we know the draw buffer ID, entities, draw buffer ID, and then we know entity ID is this. Draw buffer ID, entity ID. Then we might look up material ID, or we might defer that to doing it in the pixel shader. Or maybe we'd output that and then we would later defer the material system. That can come later. So now I know that I have a bit more of a robust way of looking up. And then this function, render mesh material instanced in here, we just called it render meshes material now. And these are actually instance buffer, instance draw query, and we also need to get we need a double query, which is one of the frustrating things about the current setup, how to register these functions. I have to make a tuple of queries, and the other query is world buffers, and we only need that as a read only, but that's fine. Okay. Let instance draw query world buffers. So I called those world buffers in the end, and I think that's starting again to take shape. The world, Bevy calls it a world, and we have a set of buffers for the world which contain all of the draw call data for entities, all of the lights, and all of the materials. We may have multiple light buffers depending on how we want to store the data. So that's going to start to take shape, hopefully sooner rather than later. I'm itching to get something a bit more, a bit more impressive running now. I've kind of been chewing the fat of different draw call mechanisms for a little while now, but I think it's all useful work. So we've got an instance draw, and then so with the world buffers, we know there should be just one. I'm in, annoyingly, a universe where I don't have Rust Analyzer working again. So I'm in the dark. But if I do that, that's not going to do anything. We need to register. Let's see how it handles it. Right, so we failed to compile shaders. Let's clean these bits up. User, okay, draw IDs. Draw IDs is draw indices. No, we don't need that one. Buffer IDs is that. Entity data, C buffer instance data. That one is just purely a test, and it's purely a quick way of just setting up a C buffer and making sure it works. That one should move to a test. Then we've got view and draw push constants. And I think, again, I know draw push constants are fairly well used in here. It's just the C buffer instance data, I think. But these ones, texture 3D, well, I suppose in a way they could be considered debug because they're just basically drawing and passing through a generic mesh which can sample a texture 3D, passing through a generic mesh with vertex buffer instancing. So just thinking aloud here about this, I'm always trying to consolidate and sort of refactor. I believe I can actually take that out as well. What are you doing? Okay, I had a typo in there. Material buffer has a colon on it. Still failing. Draw buffer ID. Draw buffer. And these scoped C buffers, I think they're working much better now. Reload complete. Okay, that's compiled. And it's not complaining about anything. We're calling render meshes vertex buffer instance still though. Okay. Render meshes material. Is that a function call? No, still working. There are two of these. No. Grid meshes. But that's not been registered, so I don't know how render mesh is material. It's being called. Okay, so that's missing function. And render mesh's material exists in some way. I'm just going to call this one bindless. Render meshes bindless material, because that's what it is. Render mesh. I think maybe that might have been registered somehow in this instance. Okay, I need to register the function in this big old list. Wonder why we get a couple. Yep. Render meshes view name. Then it had the two queries. No, that's correct. And that's the two queries that we care about: instance buffer, mesh component, and pipeline, and then draw with the world buffers. Expected 3 elements. Oh, that doesn't need parentheses, because it's just a single query. That was only a warning anyway. Remove these parentheses. Yep. Render meshes bindless material. Here we go. Alright, render meshes bindless material is being called. So now we're in here, but we weren't doing anything. So we don't set the pipeline per mesh, we just set the pipeline once. And that means the view has a pipeline. Is that that might be an array? No. View pipeline. So that means there's one pipeline for this entire view, which is correct. Then we can set that pipeline and we can set the camera view projection matrix. We get the queries, we iterate over, and we can just bind this heap once as well, because we're not changing anything. And then for each batch, we have a different mesh, index buffer and vertex buffer, an instance batch buffer. This can be further optimized later, which is what I'm working towards. We make a draw call. So per instance, we want to set the push constants on slot 1, and we have 4 with 0 offset. So what we need is a vec for u of the world buffers. Now world buffers 0. There should be 1. We can just do, I'm just going to get these queries right at the top or anything else. If so we can throw an error. Sorry, that's wrong. I'm trying to get better at remembering the syntax for doing errors, because what I was doing for a little while was just copy and pasting them all around. And it's not that complicated. Just this. Okay, hotline, rs, ECS, world buffers is length 0. So we expect that can return that. So that's just some sanity checking. So let world buffers query. I mean, to be honest, it should only be 1. And also, I think in the long run, these might not be a component, and they could put them in PMFX. But I'm just sticking them there now, just for the ease of it. So world buffers, right? Here's where I'm having a bit of trouble now. I'm gonna just quickly. Let's get rid of that. Just going to quickly open this into, this is my other one. This is my plugins repo where the Rust Analyzer does work. Let's get into ECS demos, render meshes, material. Oh, Bindless. Here we go. Back for you. That can pass as a n. So let's see. Query world buffers is a, what are you? Huh. So I have to do this, do I? I have to loop over in world buffers query. Now you don't have to set it in there, so I can just do this. I push the push constants, world buffers. I don't have to do that, but hold on. I will do an error handling. We can set them and then break, and we can do let mut set So just set a flag to say, yes, we've set the world buffers. If world buffer's not set, and that's fine. Okay, it's not a super error, it's a hotline RS error. The message, and that can be string. And actually, this one, I'm going to change that so we don't have to do the unstring. So we don't need a pipeline on a mesh. Okay. World buffers. No. Draw buffers. World buffers. That's all we have so far, right? But even then, we could just take the whole world buffers instead of packing it in. I'll do that as I refactor. Or not, because I need to call get SRV index. Oh my word. Let me move that out of there. Just so then it's going to be nicer to add the other ones in. So these might change between runs, and that needs to be, it's an option. Now I sort of wish I'd made that an error, because then I could just pop it, or just use the question mark operator on it. Right, so bind the shader heap, set buffer, the world buffer IDs, error handling for that, instance batch, draw calls. So right, let's go. Come on. Come on. Right, those ones bad. Oh my god, I can't see. There's so much visual clutter. So much visual clutter. What is this? Oh yeah, we don't want a pipeline component. It's part of the pipeline. So we're not changing pipelines all the time. That's the whole point of this. We bind one pipeline. So it's a bindless material. In what might happen, currently it's going to do, it's like a forward bindless in a way. We look up the IDs and the shader is going to apply, you know, a basic PBR. But we could defer that material further in the future and then do just write out the IDs and then do passes which can use then different materials. So it's like geometry passes. I want to get down to as few draw calls as possible. So we spawn that. We've got mesh material instanced, which is not the pipeline, and that's part of a batch, which we look up. This is just This is going to be string new. Oops. Okay. Bunch of warnings. That's from the... Oh. Fantastic, though. So this is what I did yesterday. Pause updates. It's spewing out messages, though. The problem is I think these need to be consumed somehow. So my root signature is incorrect. And this is really cool that this is here. While I'm here, I might fix this up a little bit more. No, what was that? But previously, what I would have had to have done is something would have been wrong, and I would have been like, "Oh, what's happening? I don't know what's going on," and I have to boot into a debug mode, go into the debug console, and get those outputs. And now I'm getting the D3D validation outputs, albeit I think they're not being cleared, so this might just be never-ending console spew. I'm going to check that now and do a few things around this area of code. So that's going to require me going back into the client and where we're handling those errors. Info queue. Okay. So first thing I'm going to do, I'm just going to print the length info queue. Just to debug it. I mean, I could put a debug breakpoint, but I'm just going to do this. Info queue.len info queue length. Let me just run that again. I think I might have to sort of consume those messages properly somehow. Ah, damn, I meant to comment out the actual error spew, because that might make it not possible to spot. Come on. Let's close this. And then we go again. Is that the right one? Oh, it doesn't matter if I do it from here, actually. I'll stay in the same Xcode. Not Xcode, VS Code. It would be nice if I could just use one instance of it. I should probably ask about that to see if anyone can help. Right, okay, so this, look, the info queue is ever growing. Ever growing. Get info queue messages. Oh, go on, go to the right place. Here it is. So now we've got get num stored message, get message, and then get message count limit, clear storage filter, storage filter, clear, push empty, add message, add application message, set break on severity, set break on ID, mute debug output, get mute debug output. Get num stored messages. Discarded. No. Well, that's not it. Get message. We could track the index of the message queue where we left off from the previous time, so we're only handling. But it would be nice to retrieval filter, add message. I'm gonna have to just briefly search for this. 3D12 info queue clear messages. Clear stored messages. So that means I can do all of these, loop over them, and then info queue dot clear stored messages. Right, that should clean this up. Oh, it's one. There's one message each frame. That's fine. Okay, so now this kind of behavior of what it would have been doing is it exponentially growing. What's it called? It's kind of like a factorial. Is it? Oh, go to the right file. Right, there we go. So info queue length is nicely being flushed. And that's just going to have one message spewing out per frame, which is the issue with my B1 slot on the descriptor. And that might be down to the fact that I changed the name of the push constants, I think. And I changed the name of the push constants in the shader, but not. Okay. So I think I can fix this in data. Now. So, buffer IDs, push constants. If I go to here, draw IDs, push constants. Buffer IDs, push constants. So now it's, there we go. Oh, this is all right. Well, it's drawing them. So we're back in business. I think that my problem before was I would be crashing because the index in that shader resource view heap was not being correctly maintained. Now if I do pause updates, this is cool. This stops any updates, so I'm not going to continue spewing out messages. The current root signature declares parameter 1 with type 32-bit constants, num 32-bit value 0. Interesting. So slot 1, num 32-bit values. It should be 4. I'm going to look into debug shader metadata. Debug tips. No. It's in data shaders debug JSON. material instanced. Okay, let's go to there, instanced. Vertex layout. Descriptor layout is what I actually care about. Okay. So Friday's push constants thinks it has 0 values, but there are values, and that's down to PMFX. So there's a little utility function that gives you this. Uint's in there. Right. So now what it is because the structure, the data type, is not redirecting. I think it's going to be important to switch to this constant buffer approach. The scoping is much better, and then it makes C buffers a bit more similar to structured buffers. It's still useful to support the other way, because then you can put any kind of shaders. But for this now, what I'm going to have to do, I actually started to propose a new workflow. Resume updates. Just quickly, I think what I'm going to do, in the shader, I want to there we go. So now they look a bit better, I think. Cool. Let's get rid of this spew. This means I'm going to just have to be doing a little bit of work inside PMFX. I'm going to just go if num values equals to 0. While I'm here, I have got a few tasks I'm going to do actually. How long have I been running for? Let's see. Might just call it a day for now and then go offline. Yeah, I think I'm going to call it there, because I'm just going to have to dig in PMFX. I have some code or some other fixes, and I might just take these offline and wrap them up, because it's Python's a bit, I don't know, it's not as interesting to look at the builds, watching builds come through. But this is sort of minimizing shader duplication, validating states exist in PMFX, because sometimes you can delete or incorrectly name like a raster state or something along those lines. And I think that's important to just validate that further up the food chain, as it were. So there's a bit of stuff there. The main thing here is I already did a long stream today, but obviously the audio wasn't working. So I'm going to call it there. It's getting close now. Let's just quickly run again just to kind of see it. Here we go. We're drawing all of these by looking up the entity ID in a big old buffer of world matrices. In future, that can be extended to account for more data. We might need things more than just a world matrix. But then just for entities or just for draw calls, we might not need that much. Materials are going to come into this and they'll be the same. They'll just be another buffer, material data, and that's just going to contain lookups for textures. So there's quite a lot of indirection there. We're looking up an ID from the vertex buffer. We're looking up the world matrix from that ID. We're looking up the material from that ID, and then from the material, we'll use those texture IDs to look up textures. So indirection, and but that's how it's supposed to be, and it just means we can do everything on the GPU and offload the CPU stuff, or at least draw call wise. Yep, so I'm going to leave it there. Cheers.